So that was mildly irritating because I didn't have the settings on when I wanted them to easily. Now I kind of have got I wanted to turn the phone round again this time because I'm deeply engaged in some sort of chemistry at the moment. The chemistry of carbon, really. There's pure cellulose burning. That's precisely what I wanted to point out. I almost want to fetch that out of the fire. In fact, I'm going to attempt to do so. It was cellulose on a roll. I think I could extinguish it. Oh, I've broken the roll. Still, its layered structure, like a newspaper, is still apparent. I'll put the flame out. Right. Notice how it lifts as it glows and continues to extinguish as it oxidizes over the surface. If I wanted to put it out quicker, I could remove the temperature from it by applying, say, that edge, and then I would be left with something that was a little bit flaky, really quite flaky. I want to put it out completely. In here you see the same thing taking place with cardboard, although the ash content is probably a little bit higher because I didn't get to it early enough. This is still continuing to oxidize at the edges. Look at that, in sort of a slightly infuriating way. I have not quenched it enough. But that was because I was kind of grabbing my phone as I was doing it. Right, laser-induced graphene takes just about whatever you like. I mean, it could take a coated paper, it could take raw cellulose, it could take cardboard. But the one we really like as chemists at the moment, I'm sorry to say, is polyamide film. Polyamide film produces the best laser-induced graphene, frankly. I don't think the others are going to be in the same league. Besides which, there's been more work done on the others. And what work has probably been done on toast and cellulose and polythene and cling film, and for that matter aluminium foil, Kaptan tape at high speeds, is probably minimal globally. It's a bit embarrassing, really, that we can't catch up. So let's just do what we're trying to do here, which is to reduce the volume of some packaging material using a solvent. The solvent is petrol. I've just tried white spirit. It wasn't any good. I think acetone would be the one to use. But you'll be quite pleased to see that despite that rather strong smell of petrol in the air, well, you can actually hear that this is dissolving in it. And why am I doing this and confusing a conversation about? This is, of course, going sticky. And I think you might find that this substance is called napalm. Polystyrene, petrol. gets you gloop, actually. It's what it gets you. It gets you a gloop. I want an insulating gloop to go around all the safety of all my electronic components, actually. Specifically little components like these. They don't survive unless they're protected properly from the atmosphere, so you need an insulating gloop around them, really, I find. Not sure quite yet what gloop to use, but Tesla, I gather, use quite a lot of gloop. They just want to glue everything together in their batteries. But you see, they basically seem to remember that going faster. Anyway, let's let it go for a minute and return to the subject under discussion was graphene, which I was going to alright, so it's a crazy place to do it down by the fire, isn't it? So let's clear a little bit of space here. I'll roll out some aluminium foil for the purposes of illustration. A conducting surface, although this kind of foil, when you buy it, often has got plastic coating reducing its electrical conductivity, which is slightly annoying. A good friend of mine uses that for fuses. Here also is my metal scrap recycling, but at the moment, I'd like to come to that in a moment, please. And sorry about the biscuit, but the biscuit, actually, that too has got a purpose there, because we're talking about layering onto absorbent surfaces. Here's another form of absorbent surface with some quite good protective function to it. Oh, a sample electrical connector. For the moment, I'm just going to put the graphene on here and put some tooling out, ready for a bit of a thing. I've not really prepped the surface to a cleanliness hygiene level of sufficient for chemistry. It is, after all, my draining board rather than my lab surface. Right, let's get out the bloody way. Put that there. Do I need pressure? Yes, I might need pressure in a minute. To illustrate the fact that you might need pressure. Tooling, no. Charge the phone. Could put the phone on charge just for a minute while I talk. Araldite not required at this point in time. Put this and this away. Gloopy gloop. Right. Alright, well, you've got to see this then, alright? Because it's quite fascinating. I've just spent all that time, TTT, watching this process, trying to eliminate the movement of the oxidation, which is clearly tracing out edges, alright? And in the process, I've sort of managed to contaminate my pure cellulose sample here. But when I pick this up, it has some integrity to it still. I know I've dipped it in sawdust, but I'm going to put that out as sample number 1. Alright? That could, of course, be the cardboard inner roll, because there was a contamination between the pure I'm going to call it toilet tissue, and the cardboard roll, which also became part of the combustion process. So, and here in most frustrating mode, the actual plastic coated or ceramic coated magazine paper, a completely different product effectively, has been generated with much greater flake size and flake integrity. In other words, these flakes break up on pressure. This one that has the fibers still in it is fascinating, and I've contaminated the 2 samples, and you can basically see what a nightmare the situation is. But let's just say that that's what you want, and then say that what the objective is to have this graphene in its layers as thin as possible, somehow glued or fixed or crimpled in some way evenly across the surface. If you can imagine doing this at tiny scale, well, you're a better person than I, because I'm not going to stand here and do it for every single atom, obviously. But I do believe that's what we're trying to engineer. Possibly we're trying to engineer that this stuff is attached to a piece of Kaptan tape. Now, since we want to have basically carbon in here, I'm waving the scalpel, at this engineered at a very fine scale. I hesitate at this point to say how good the engineering will have to be, but I do think that if you introduce this sort of knife across the top of this surface, in a way we will be able to sweep up and cut and separate a solid product. Now, as soon as you produce this solid product, sorry about that, it's going to want to oxidize in the air, and it's going to want to sort of collapse. So you have to introduce something at this stage to carry it, ideally probably an oil, something larger than a water molecule needs to sit between that and that. The oil could then be extruded later. But the objective is to try to maintain the sheet size. Filtered later. Do I mean filtered? Don't know. Maybe we're we would keep it as its like light form, like this, as if it were a packet of crisps. Yeah, this roll here rolls up rather nicely to produce an electrode at this end. Get me? And another sheet comes the other way with the polyamide in the middle. And the extent of the amount of cellulose and laser induction that goes on at the various layers and the various intensities as the sheet moves through the machine is to be decided, of course, contingent on the machine, but we're trying to engineer this kind of thing at, I might say, this sort of scale. Now, the extent to which we want to go robotic on the manufacturer, is of course a very topical subject at the moment. I'm going to introduce that aluminium entirely to the fire, having parcelled up my biomass in it. I might wrap this paper in one way or another. Yeah, that would be interesting. Time to stop rambling and revisit the Kickstarter.